Hello and welcome to the quick start video for TestPro. I have on camera here my TestPro remote. I've got it labeled as remote just so we know this for the video. My main unit is off screen as we go through this demonstration. I do want to show you some physical attributes of the tester. Of course, you've got your power button on the front to turn it on or turn it off. You've got a hard home button which will take you back to this home screen no matter where you are. You've got the test button, so if you need to go in and modify any of your parameters while you're in the middle of testing, say change the cabling, change the limit, you can do that, and instead of having to go back out through the menus and go back into the test, you can simply hit that after you've made your changes and it will run the same test that you've previously run. Working our way around the tester, on this side we've got our charging port for your AC charging adapter. There's a 1 gigabit Ethernet port here for testing 1 gigabit SNR. This will also allow you to test network discovery. So you can do switch detail, you can blink a port on a switch, do network discovery, those type of things. USB port is for offloading your test results, upgrading firmware. Also, you can use the Etamax USB Wi-Fi adapter to take advantage of our Wi-Fi testing capabilities. The small USB is for connecting to your computer with the USB cable so you can offload test results or upgrade firmware. On the back under the kickstand you'll see your serial number information. To put an adapter in or remove an adapter, there's two buttons here. You squeeze these and pull the adapter out like this. To insert a different adapter, you'll simply align that up, squeeze those buttons again and push in until it bottoms out and then release the buttons. They are hot swappable, so you don't have to power your unit off to swap back and forth. Now, I'm going to be demonstrating today using channel adapters. The process is basically the same whether you're using channel adapters or you're using a permanent link adapter. It just matters how you set up your limits, that they are appropriate for the adapters. I am going to go through some basic settings real quick here. If we go into the settings menu on the unit, here is where we can go in, click on display, and in here you can do things like change your date format. You can click on edit date and change that, set up your time zone, those type of things in here. Also your sleep mode timers and your power off timers are in here as well, where you can click in and go change those. You can also adjust the brightness level of your display and adjust the audio volume by clicking in here, and you can change the language by clicking on language. The other settings that are important to note in here under certification, you'll have the units for feet and meters. I would leave the y-axis alone. Most people don't even change that. Then the result autosave, you can set it to automatically save test results, although a word of caution, make sure that you don't skip over a port if you've got it set to autosave, because the tester will not know that you've missed that port. Auto start, when you select that, you can actually go in and have it automatically start as soon as the testers see each other. And combining auto start and auto save can help you speed through testing. But again, be very cautious to make sure you don't miss a port when you're running through the testing. The long cable mode is only used if you're testing something longer than 500 meters, and you can contact us for information about that. If you're testing shielded cabling, you can turn on the show shield integrity so that the wire map will actually show if there are changes in the shield along the cable. And then under device, we have information like the calibration date, the serial number of the tester. All that information is available in here, as well as whatever adapter you've got connected and the serial number. So this is all information that you will find in device. The USB menu here will also appear when you insert the USB drive into the side of the tester, and this is where you can copy off your test results, you can import a custom label list, and upgrade firmware if needed. So I'm going to hit my home button on my main unit. That'll take us back to the home screen, and then we'll set up a project. So we're going to go into the project right here, and I'm going to click on Project Manager. Then I'm going to click Add. And we need to give the project a name, so I'm just going to call this Test 1A, just to give it something simple. Click OK, and yes, I want to set this as my current project. and we're doing copper certification. So I want to make sure I choose copper certification and click Save. And now I see I'm selected, I'm in that project. I can hit the back button, and now we see the project details, and here's where we want to go in and change the parameters. So we'll click Edit Test Profile, and the first thing we want to look at is limit. I'm going to do Cat 6A channel, but if I wanted to do something different, if I was doing permanent link and I had my permanent link adapters, I would click on this, and I can click on TIA, and I can click on permanent link, and then I can scroll down and find my Cat 6A permanent link. Now you'll notice in both channel and permanent link, you'll see parameters that have a plus or a plus plus after them. Those are the optional parameters. They're not required by the standards, but you want to choose those parameters. If you intend to use this cabling for power over Ethernet, you want to make sure you include those plus parameters so that you'll know that it will support that power over Ethernet. The plus parameters add the DC resistance on balance, and the plus plus in the channel will, in addition to DC resistance on balance, include TCL and ELTC-TL. You've also got options here again for channel. You've got MPTL. Note that if you are doing MPTL testing, you want to make sure that you have a patch cord adapter on the remote end that is the same category as the cabling you are going to test. Other areas where you can go in and set limits here, you've got international, the ISO IEC limits. You've got patch cord limits if you're doing single pair Ethernet or coax. A lot of that is in there as well. If you're doing extended distance cabling like Game Changer or Superior Essex extended distance cable, you can find those under vendor, and you'll see Page Datacom and Superior Essex in there. So if you're doing those extended distance cables, that's where you'll want to choose your limit. The wiring, this decides whether you're going to be showing 568A, 568B, so based on what you're testing, you can change this. There's also accommodations in here for crossover. The cable, we can select our cable type. I've got a generic in there right now, but we can edit this and we can go down and choose a particular manufacturer and go into that manufacturer, and then within that manufacturer we can go in and pick the cable that we need. Also, we can create a cable. So if we went in here to generic and we don't see what we want, or we didn't see what we want in the manufacturer, we can go ahead and click Add, and we can add our own new cable here, so we can put in a name for it. I recommend putting the manufacturer name and a part number here, and then you can choose what category you want. You can select UTP or the different shield types, and then you can put your NVP value in, which you'll have to get from the manufacturer's documentation. That's important for the accurate length measurement. And then you can click Add and save that. I'm just going to leave that alone, just wanted to show that to you. We're going to leave this with generic Cat 6A. When you want to change the connector, same process. Click on Connector, click on Edit, and you'll see a listing in here. You won't be able to create connectors in here, but there's a listing, or you can use generic. And then for the label scheme, you can go in and edit, you can create a label scheme. So we'll go ahead and click Add, and then we're just going to give this, I'll just call this TDQ, just give it a name, just make something up. And I'm just going to do rack panel port. So we'll do building 1, I'm just going to do B1, and then we'll do rack 1, panel A, and then we'll do port 1. And for the port, I'm going to do 01 because we're going to have double-digit number of ports, so we need to have the same number of characters for start and end. And then for my ending panel, we're still going to be building 1. We're just going to keep this simple. We'll do rack 4, so we'll have 4 racks in this building. And let's say we have 4 panels in each rack. It'll be small, so we'll do D for the 4th panel, and then we'll make these 24 port panels. So we're going from rack 1, panel A, port 1, to rack 4, panel D, port 24. And then I click Add. And yes, I want to set this as my current label scheme. And now if I hit Save here, I see that my label scheme is built out. So I'll close that. Now we can add the operator. We click on Operator, we click on Add, and I'm just going to put my initials in here and click OK. And yes, SC is the current operator. So now my project is set up. Here are all the parameters. So now that my project is set up, I'm ready to start testing. So I'll hit my home button on my main unit, and I've got my main unit off screen, and here's a patch cord I've got coming from the channel adapter. I'm going to go over here to this first port. What I've got set up over here, I've got a panel with loops of cable behind it. So what we're going to do is I'm going to go ahead and plug another cord into my remote tester here, and then the other end of that patch cord will go ahead and connect to the corresponding port for the other end of the cable behind here. So we're testing between these two ports here. We see we get an automatic wire map on both ends. So we can see, as I move this, we see we've got the same information on my remote here that you see on the main unit over here on the left side of the display. So we know we've got a short and an open. If I click the middle of the wire map, from either end, I can see from that device, whether it's from the main or the remote, how far away I am to these events. So in this case, I know it's the other end of the cable. If I was to do this on my remote, we'll see this pop up on the remote, and we'll see how far we are. And we'll see if we can get this on camera so you can see it. And it looks like we're right around 9 feet to that. That's probably my patch cord length, or a little beyond. So here's from the remote, so it's going to be behind this jack right here. So, and it is a short and an open that we've got there. So let's go in and look at some other links here. Let's go to the next one in sequence. And in this case, we see this is actually a crossover that we've got here. So let me go to this next set. Okay, so we get a good wire map. We're going to go ahead and run a test. I'll click Auto Test. And we got a fail. So this cable failed. We've got an issue here. And we can see we've got crosstalk and we've got return loss issues. I can click on my Details tab here, and I can scroll down. I can look at these plots. So if I wanted to look at the next plot, I could click that. And yeah, we see we've gone past the limit line. But let's scroll down to the bottom, because when we have a failure like this in the field, we want to figure out where along the cable this failure is. First thing I'll look at is RL locator. This is a TDR trace of my return loss. And I can see I've got big spikes at both ends. Looks like the far end is a little bit worse. It goes to a broader spectrum, and my cursor has jumped right out to that, and it tells me it's at 96 feet. So it's going to be at my remote end. So I can actually pull that same information down on my remote. So no matter which end of the cable I'm on, I can grab this information, and I'm going to scroll down to my RL locator, and I'm going to pull that up on the remote. And in this case, on the remote end, we can see that it's showing me something that's closer to the remote than it is to the main, which that correlates with what we're seeing on the main. Same thing for crosstalk. So if I click Next Locator, I can see I've got a big spike at my far end here. I've actually got a spike in the middle here, and I've got a spike at the near end. The big spike at the far end is the worst case. That's the biggest problem. And in this case, it was pairs that were intentionally untwisted a couple of inches to create the crosstalk. The spike you see in the middle is an actual kink in the cable that was smoothed out, but still is producing an issue. And then there's a little bit of crosstalk on the near end here. And again, I can do the same thing on my remote. If I pull that up, we'll see on the remote, you'll notice that the larger spike is on the left side, which means it's closer to that remote than it is to the main. Now this spike here is a little bit obscured by this pair 3645, but that does tell me that pair 3645 is the worst case, so I know it is my blue pair in the middle and the green pair that is straddling it. Same thing with your return loss locator. When we looked at that, in this case we see it's 45. It's the blue pair that's the worst case. And you can isolate these pairs as well. You can select the plots and just show a single pair if you wanted to. And you can see that spike from that single pair. So we can save failed results if we want, in case we wanted to use that as a punch list and come back and overwrite it. I'm going to plug into another link now that should be a good link. And we have a good wire map, so I'm going to go ahead and run an auto test. All right, 6 seconds later we have our results, and we passed. We can go ahead and save this, If we wanted to overwrite that first one, let's say we corrected it and we reran the test, we could just click on that. It would warn us that we were overwriting. I'm just going to save it as the next one in sequence. I'm going to run another test really quick. And what we want to do with this test, let's say you have a one-off and the label is not part of your label sequence. You want to save it as something different. Click Save As, and you can type in literally whatever you want in here and click the check, and it's going to save that. So now we have that result saved. To offload your test results, you'll simply insert the USB the side of your main unit. Just putting it into the remote there. I'm going to insert it into my main, and we'll get the USB menu will pop up, and we're going to click Copy Test Results. I'm going to go ahead and select that project we're working on. It will warn me that I'm not 100% complete because I haven't tested through the entire labeling sequence. That's okay. It's just giving me a gentle reminder. So I'm going to go ahead and click Yes and offload the test results for the tests that we've already completed. And we've got 3 results copied over, which are the tests that we just ran. And now those results are ready to be offloaded and managed in our TestDataPro software. And that concludes the copper testing portion. Next we'll cover the fiber testing portion. I've removed my copper adapters and inserted my fiber adapters, and I've already connected my reference cords. We're going to talk about how to properly connect these reference cords before we go in and set up our project. So I'm going to show you a diagram here. We've got one reference cord to go from the TX port, transmit port of our main, to the RX or receive port of our remote. We've got a second cord that goes from the TX port of the remote to the RX port of the main. This is called the one jumper set reference method. It may be confusing because we actually have 2 cords, but one jumper means there's one jumper from the transmit, the light source, to the receive, which is the power meter. So you've got one from this light source to this power meter, one from this light source to this power meter. That is the one jumper method. This is what you must use when you're testing a fiber link. When you're testing fiber from one panel to another, you use the one jumper reference method. The 2 jumper and 3 jumper methods are used when you either have 1 or 2 patch cords that you're also testing on each end in addition to the link. But most of what you test is going to be that link from panel to panel. That will be the one jumper method. After you've set that reference, you're going to connect a second patch cord to each unit. You're going to disconnect from the receive port on each unit and add a second reference cord. So now both testers will have 2 reference cords. Then you can couple them together and run an auto test to make sure that you don't have excessive loss in the launch cords that you've just added. Once you've done that and confirmed that your launch cords are good, you disconnect from that coupler, and you'll be setting up here like we're showing in this diagram, where this blue is our fiber under test, and you've got 2 cords on your main unit, 2 cords on your remote unit. They're at opposite ends of your fiber under test, and you'll run that auto test. Now, one word as well about the connections. This connection right here, if you're testing LCs, our default connector here is a Frank Charlie, an FC, and that's for the LC kit. If you're testing SCs with one of our SC adapter kits, you can use an FC on this port, but we also have the adapter to change that to an SC, as well as changing the receive port to an SC. But I want to show you the FC connector up close, because that FC connector has a keying that you need to be aware of when you go to test, when you go to do a set reference. So let me pull up a picture of that real quick. And here we go. So let me zoom in on this. So this is the Frank Charlie, this is the FC. So this would be on your test reference cord. There's a little tab. You have to make sure that tab aligns with the notch in the report on your tester before you tighten this down. If that's not lined up, you can still tighten this connector down, but it won't be a complete connection. There'll be an air gap, and you'll get a high loss or an error when you're trying to do your set reference. So just make sure that when you connect that right there on that Frank Charlie, that you line that tab up on the test reference cord with the slot on the port on the tester. So now what we want to do, We want to go ahead and set up a project. Very similar to the way we set up our project in copper. We're going to click on project. We're going to go in here and we can click on project manager and we'll click on add. Now we can stay in the same project if we want and just use our limits. But I'm going to show you how to add a fiber project real quick. I'm just going to make something up, click OK. Yes, that's my current project. And it's going to be a fiber project. So we're doing multi-mode fiber here. I'm going to click on that. I'm going to click Save. And we'll go ahead and hit my back button. And then we'll go in just like we did with copper. We'll edit the profile. And the first thing we look at is limits. So we want to go into here. Now, when you test your reference cords in a subsequent version of firmware that will be issued in March of 2024, under loss budget you will see an additional button for testing the test reference cords, and you can use that when you do that test reference cord test, or you can just run a regular test and save it if you like in the interim. We're going to be looking at certification, but loss budget, you can actually go into loss budget. If all you're testing for is a flat loss budget number, this is where you input that number and click Save. Most of what we do is going to be certification, so we're going to go in here, and I see that I am set up in the reference grade, but I'm going to show you how to change the limits here. We're going to click on Standard Limit. We're going to go to TIA, and we see here for my multi-mode I've got several different ones. The -E version is the latest version of the standard, so I'm going to choose that. We're going to choose the 568.3-E multi-mode reference grade. Now the difference between reference grade and standard grade is how much loss you are allowed for the mated pair at each end. I'm going to choose reference grade. Now in reference grade we get 3 dB per kilometer at 850. Based on the length of the fiber we get 1.5 dB per kilometer at 1300. The connectors on each end, 0.5 is what we're allowed in reference grade. If it's standard grade, you get 0.75. Most of what you're going to be testing would be reference grade. Additional connectors, these only come into play if you've got a cross connect. So there's an additional panel in between the 2 points where you're testing, where you've got 2 panels in that interim point or an intermediate cross connect, and you've got to account for the mated connectors on each end of the patch cords between those 2 panels. So you'd add 2 connectors here. If you have any splices, you need to include them here as well. Now, splices can also include mechanical splice on connectors. So if you're using a mechanical splice on connector at each end of the fiber, and the connector mating itself is already accounted for here in the end connectors, but you also need to account for that mechanical splice down here. So if you've got mechanical splice on connectors on both ends, you need to put 2 in here to make sure you account for those. Once you've got your limit set up, you just click Save. Now, you can change the configuration. You can do loop back, but we're doing certifications. That's going to be either dual-ended single direction or dual-ended bi-direction. They're essentially the same test, but if you do the dual-ended bi-direction, it will run the test and then it will advise you that you need to flip the fibers at each end. When it tells you flip the fibers at each end, it doesn't mean flip them on the tester. You have to flip them at the panel where they're plugged in. And then you click continue and it will run the second part of the test so that you end up testing in both directions. We're just going to do dual-ended single direction right now. Cable, just like with copper, you can leave it at generic. You can go in here and edit. You can go to your generic multi-mode and choose a fiber in here. You can go through the library and choose one from a manufacturer. The connector, you can go in and choose the connector if you want. You can change it. Just do a generic or click on one of the manufacturers here and choose the connector. We're just going to leave that at LC. Label scheme, the label scheme setup and the operator setup is going to be the same. I can go ahead and use that same label scheme I already created because it's in here. So I'm just going to do that. And so I've got that label scheme set up. And then for operator, again, I've already entered my initials, so they're already stored in here, so I can go ahead and use that. Or I can add a new one if it's somebody different doing it. So now our fiber test is set up. I want to go ahead and do a set reference. Now it's important that you let your adapters warm up in the tester for 5 minutes prior to doing a set reference. Mine have done that already. And if you try to do a set reference prior to that, it will give you a warning and tell you it needs more time. So I'm going to go into Tools, You've got a lot of tools in here. There's a built-in visual fault locator. The port is right here. DC set reference only comes into play if you're doing hybrid powered fiber. There's a standalone light source and power meter mode. And then fiber inspection. If you've got the scope, it plugs into the USB port so you can look at the end face of the connector prior to connecting to anything to make sure you don't need to clean it. So we're going to go into set reference, and we're using the one jumper. I'm going to click on set reference. My cords are already connected, so I'm going to click OK. And what I'm going to be looking for is a reading on each end after the set reference is complete, and it will be typically within a certain range. And it's usually going to be in the, for multi-mode, it'll be in that -18 to -24 range typically that you're going to see. If it's single mode, it's going to be the +4 to -4 typically. So my set reference is complete. I'm in that -20 range here, and on my remote, I'm -21, -23, so we are good to go. I'm going to go ahead and click OK on both of these, and then we'll go back. So now what we would do is add our second reference cord. We're going to disconnect from this receive port and add a second reference cord. I'm going to pause the video, change those cords out, and come right back. So what we've got set up here, I've gone ahead and added this additional cord to each unit on each end, and then coming from my remote unit into here, into this coupler, I've got the two cords that come from my remote, and on this side I've got the two cords coming from my main unit, and they're just connected to each other with a coupler. And what we're going to do now is go ahead and run an auto test. The auto test is complete. I'm going to go to my loss tab, and I want to look at loss. So I've got 0.01 on fiber 1 and 0.00 on fiber 2 at 850, and then if I go to 1300 nanometers, I've got 0.01 and 0.00. So I've essentially added no loss with the additional reference cords. I'm going to save this, but what I'm going to do is, instead of using my label scheme, I'm going to do save as, and I'm going to call this test reference cord, just TRC. I'm just going to abbreviate it. So I've tested my reference cords. I know they're good. So I'm going to click OK. So now I have a record that I've tested that. And again, a future version of firmware will actually have a test reference cord setting in there so you know they passed or failed. Now what we're looking for, when we look back at that loss, we want to look at, for multi-mode, you should see 0.1 or less, so 0.10 or less, and then for single mode it's 0.2 or less. Some will tell you can average that and just use 0.15 for both, but technically it's 0.2 for single mode and 0.1 for multi-mode, and we were at 0.01 and 0.00, so we were in good shape. So we know our reference cords are good. Now I'm going to connect to our fiber under test, and you'll want to typically inspect and clean before you do this. So I'm going to go ahead and connect this, and we'll come right back and we'll run the test. So I've disconnected from the coupler, and I have coupled to my panel, which is up above this video screen here, and we can see I've got a connection on both sides. We're ready to test the installed fiber. I'm going to go ahead and click auto test. And we see our test is completed. We see our total length is roughly 105 feet. We see our delay. We see our margins. Then we go into the loss tab. I see I've got 0.12 on fiber 1, 0.19 on fiber 2 at 850. I can look at 1300, 0.14 and 0.19 respectively, and I see my margins here. I see my limit. That limit was calculated based on my 0.5 for made to pair on each end. That gives me 1.0. And then the length of the fiber is giving us another 0.05 to make a total of 1.05. We look at network limits, and we can actually see all the different network speeds we can run over this fiber. This will also show up on your test report. And all we do here is we click save, just like we did with our copper test. So now that's saved. And that concludes the fiber test section. Now we'll show you quickly how to import test results. So I've got my TestDataPro PC software here for managing my test results. The first thing I need to do is go ahead and create a new project in here. So I'm going to click Create, and the software will open up a window. I'm going to save this where I save all my projects in my projects folder, and we'll just call this TP Quick Start Demo. Once you create that project, you'll see that project name is created right here. Now, what we want to do is import test results. So I offloaded the fiber test results we just did to that same USB drive. So now I can go in here and click from USB, and I've got two different folders on here. I've been using a couple of different testers. This one, 4200-0071, is the one I want. I'm going to click on that, and I want test 1A, which was our copper project, and then we want the GHYT, which is what I created for the fiber. So we'll click OK. We'll bring those in. And here we see we've got our tests that we ran. And in the tests, we can go in, we've got a failed test here that we saved. We've got the other one that we didn't save. And I actually used one of my fiber labels. Again, it's the same label because we use that same label scheme. Here's our TRC, and then here's the one I just named as a report. So I can sort these by label if I want. So they're alphanumeric by label. And I'm going to save this now that I've imported these. And then if I want to send the test results to a customer, I'm going to click right here. This is my Select All button. And I'm just going to do, if they only want summary, I'll do a summary PDF. But what I'm going to do is do a single PDF. And I'll click on single PDF. I'll just give this a name, TPQS Demo. And this will open up a PDF, and I will bring the PDF over so we can see this. And when you do the single PDF, you get a summary report in the beginning. So here's our copper certification, we see our fiber certification, and then we can go in and look at each report. There's that failed report. We'll reduce the size to make these a little easier to see. And here's a past fiber report. We see that fiber looks good. See all of our details. Here's a copper test. We see all the details here. And just like fiber, we see the speeds you can run over this. And then here's the one off that we typed in a manual name for it. And here's our fiber test reference cords that we tested as well. So that is the test results. And then I could just send this PDF off to my customer. If I wanted to provide test results to a manufacturer for warranty, then what we would do is we would use this file here, this folder, this TP Quick Start Demo. Just click Save, make sure I've saved that. This shows you where you saved it. It's in my projects folder, and it's called TP Quick Start Demo. So if I go to my projects folder and I pull up that folder, I'll show you where that TP Quick Start Demo is. And there we go. TP Quick Start Demo.tpp. That is the file that you will send to the manufacturer that will include all the test results, and they can open it up in this TestDataPro software just like I did here. So that concludes our Quick Start demo for TestPro. For more information, please go to our website at aem-test.com. You can also, in the software, there's a Help tab. This has all of your manuals. So you've got your TestPro manual, you've got your TestDataPro, which is this PC software manual to help you use that. And then there is a contact button right here. This gives you the information on how to contact us for support. So please reach out if we can be of any assistance. Thank you very much.